In this video, we're going to go through complete modeling, design, and analysis of a photo frame structure in Tekla Structural Designer. I have these framing plans. As you can see, my photo frame, the hues height, the peak, and dimensions of this particular photo frame that we're going to model in Tekla Structural Designer. We have the roof plans, that is the framing plans, and the plans dimensions, and we have the sidewall framing. In this video, I'm going to show you how to assign loads, that is wind, seismic, snow loads, ground snow loads, etc. Based on the codes. We are going to assign all these loads. I'm going to show you how to solve validation errors, etc. For example, if I want to validate this, if I validate this model, you can see there is no error. So without further ado, let's go straight to create a new document in Tekla Structural Designer. I'm just going to save this. Yes. We need to go to model. We can create grid lines. Now, if I go to these plans, the out steel, the total length is 256 feet, and the width is about 40 feet. That is out steel. But if we go to this main framing elevation, you can see that the total span of this mainframe elevation is 36 feet, and that is going to be our total width. So we're going to create grid lines, not construction lines. Make sure you go for the first option, then rectangular wizard. Just going to next. For the X direction, I will go with, I think, 1, 2, 3, 4, 5, 6, 7, 8. 8, 32 feet. You have to be careful when you are inputting this length, because if you input inches by mistake, then it's going to, you have to make sure you don't confuse feet and inches if you are using imperial. Now, I want to make sure these are 1, 2, 3, 4, 5, 6, 7, 8, and the grid lines are 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, from 1 to 9. Next, here I have 3. I mean 2. I have only 2, and the span, the main frame elevation, indicated a span of that 6. Half of it is 18. Again, be very careful there, and then go to next. Next, then I can just finish. We're going to select photo frame. Select photo frame. From that point to that point. Let me go to the 3D window. Again, I'm just going to repeat from that point to that point. Here you just need to click edit. You can see this option, edit. Now the total length is 36. We don't know the slope, but we know the rise. Our rise is 3 in 12. 3 in 12. As you can see, 3 in 12. Three in 12 is about is a slope of about. You need to be careful here. 3 in 12 is a slope is an angle of about. You can go to just search it on Google. Just search on Google or just ask ChatGPT 3 in 12 in degrees. Is I think the angle is about 14.04. Okay. The LH level. The LH level is I think from this point to that to this point to this point. This is about 15 feet 9 inches or 10 inches. I'm just going to input 15 feet 10 inches. Then standard is okay, and then click OK. We go to valley. For rafters, I'm using the grade A99250, that is as a strength over 50 KSI. So I'm going to reduce the rafter section. Yes, going to click on it. You can go to 12 by that. Select rafter 2. Select again column. My columns don't have ties or tie member or parapet. I can just click OK. Here is our photo frame member. You can go to foundation and add pad columns. Then go to edit. I want to select everything. I will copy this point, that point, all the way to the end. Okay, and press escape to escape the current command, and then I'm going to model my beams. So go to back to model, then select beam. I want not concrete but steel beam. I'm going to select this option. For the section, you can go to edit. Now I will select bars, that size, or bigger, that one. Select. Just pick. Okay, I'm going now to model my bracing. You can see the roof plan, the roof bracing, and the wall bracing. To model the bracing, you just need to select bracing, then X bracing. For the bracing, you need to change this section. This one is round HSS. Okay. And then this one, I will edit. That is the section. I will select road. I think that size is okay, is sufficient. I only have two bracing at these between these grids. There. Back to that point. Okay. Now, if I go to validate model, you will notice that we might have some problems. So you just indicate there are modeling errors. Now, if I select this bracing and uncheck auto design, because if you go to this um, the brace section is not compatible with auto design. As you can see, that warning that pops up there. So if I have unchecked auto design, then validate the model again. Now the model is valid. Now I will do the same for all other bracings. Just auto check, auto design. I mean uncheck, not auto check. Then back. And between 2 and 3 and 7 and 8, you can either copy the bracing or just model. It's so easy to model bracing in Tekla Structural Designer that I find it unnecessary to just copy paste, but copy paste is always the fastest way to model in any software. Okay, we have modeled our bracing. You can add column. Um, I will change this one to edit. We need to change the column to, we need to change the rotation. I think the rotation should be 90. I don't think it's a must. We I'm not going to model these columns there on the bracing, but for this particular column, we can just analyze these like this. I'm going to come back to how we can do this later to change the orientation of columns and add these columns at this particular point. I think we need this grid, copy this grid to the points there, so that you can be able to have a point where you can insert that column, link like that, as you can see. So I'm not going to do that right now. I'll go straight now to validate the model. Once more, my model is valid. Now I'm going to add roof panel and wall panel, which will allow me now to load this building based on the code. Select roof panel, and then Sorry for that. Back to the origin. Wall panel. Go now to that direction. Okay. Validate model. The model is still valid. We can go now to loading, load cases, load combinations. I'm going to generate final envelope, add, select, and then I will include all these combinations. Okay. Validate model. We can go to wind wizard. Next. The wind speed is okay. The enclosure classification is closed. Then next. Okay, and check details there, but I'm just going to finish. Now we have already loaded this building with wind load. Now the next thing, I will go to snow load, then select snow load wizard. I have a ground snow of about 15 psf. Then okay, go to seismic wizard. Next, I will pick ignore seismic inflow below base, my risk category 2, and then site class D. As you can see in these seismic loads, for the spectral response acceleration SS and S1, you can see I'm provided with 0.184 and 0.087. How do we input it here? We're going to input it in form of, now the SS, that is S1, SS is 0.184. I'm going to input it as 18.4. And then S1 is 0.08, that is 8.7. You can see SDS and SD1 are inputted automatically, and you can see they are both correct. The first one is 19.63 and 13.92, as you can see. Okay, then I'm going to go to next. The structure type is still moment framing, resisting framing. The long period I think should be 1. Just input 1. Next, the system is moment resisting framing. Type is spatial still moment frame. You need to include one load case here. I think all dead. Then finish. The scenario is final. Then finish. I will validate the model once more. Now we can add other type of loads. I will start with the dead load. Then I have a roof dead load of 2 and roof collateral load of 5. I will select a slab. Then here, select area. The dead load does not act on the global Z, it acts on the normal. I will show you. I will demonstrate. So I have a collateral of 5 and 2, total of 7. You can use 10. 10 is okay. Okay. Now, if I select these loads, they are acting currently on global. We need them to act on normal. Now, I will change this one to normal, and you can see the difference. Global versus normal. Okay. I have a roof snow load of 10.5. But first, we're going to add the roof live load. So go to roof live area. This is also acting normal. 20 PSF. Snow load. Now the snow load act along the global. The global, I think global Z, okay? As you can see this axis here, a load of 10.5. Okay, and finally, we need to add. Okay, done. Validate the model. We go to analysis and select first order, all combination, analyze all static, can go to results and you can check anything from deflection to drifts to moments or even axial forces, and you can report all of this. I'm not going to focus on this. I'm going to go to design. I'm going to design still static. All my members are passed, but my bracings not yet designed. Go to window, then check connection. Update connection. You can export to idea statica. Okay. I will go now to foundation, design pad footing. Then the final step is you can report members, and then we can create drawings. Go into drawing manager, going to select isolated or display details, add content, drag all of that, then view drawing, then okay. Isolated foundation details, add content, view drawing, okay. Okay guys, that marks the end of this video. I will see you in my next video. Thanks for watching.